Okay, let's take a look right now. Not using a calculator, let's take a look on how do we do this. So using the rational root theorem, I'm going to start by first I'm going to identify all of the factors of the constants. So plus or minus 1, 2, 3, 4, 6, and 12. And then I'm going to identify all of the factors of the leading coefficient, which is 1. This is nice. There is going to be no fractions. Everything will be an integer. So I'm going to try positive and negative 1, positive and negative 2, 3, positive and negative 4, 6, and 12. So if you have to list them, which you will for your test, you have positive 1 and negative 1, positive 2 and negative 2, positive 3 and negative 3, positive 4 and negative 4, positive 6 and negative 6, positive 12 and negative 12. Those are all the possible rational roots. So I'm going to start by testing positive 1. There's no calculator to be used on this part, so I'm going to start by testing positive 1. This is what I refer to kind of as that magical number we're going to test back to. And I have a 1x cubed, a negative 6x squared, a positive 5x, and a positive 12. So there is nothing missing. I don't have to put a 0 in any of those places. The degree is 3, 3, 2, 1, and 0 for x's. All right, so D Mama, we're going to drop down the first number. I'm going to do this very lightly in case I need to erase. Multiply to get 1, combine to get negative 5. Multiply to get negative 5, combine to get 0. Multiply to get 0, and I don't receive an answer of 0. That tells me that 1 is not a solution to this polynomial. Next, I'm going to try negative 1. So 1 doesn't work. Let's try negative 1. Drop down the 1, multiply to get negative 1, combine to negative 7. Multiply to get 7, combine to 12, multiply to negative 12. And finally, I do have a solution. So negative 1 is one of the three solutions. X equals negative 1. That is a solution. So now I can use factoring as a way to solve this. And if factoring did not work, I would rely on the quadratic formula. So 0 equals, there's no x's, 1x, and 2x's. Let's see if we can factor this. What multiplies to equal positive 12 combines to give us a negative 7. That'd be negative 3 and negative 4. Because the leading coefficient is only 1, makes it much easier. X minus 3, x minus 4. I'm going to set each of those factors, each of these equal to 0, and I'm going to solve. So one answer is 3. The other answer is 4. So I have three answers of negative 1, 3, and 4. If I plugged each of those numbers into this polynomial equation, I would get an answer of 0.